Sometimes identical object questions are quite disguised. Graham walks 8 blocks from his home to the library. He walks 4 blocks to the east and 4 blocks to the south. So if we draw a picture of this, then this would be his home with an H. This is not very... And this would be the library. Does this make sense that this is where he could live and that's where the library is? He would go 4 to the east and 4 south to get to the library. Now, how could he get to the library? Okay, I'm going to just change this up a little bit. I'm going to change it to bright green. Oh, that's too bright? This green? That looks better. Let's do this part. Let's do it all in green. Is that green okay, or are you no, too bright? Oh, yeah, let's go with that one. There's our green. And the question becomes, how many different ways can he walk to the library? And we're going to assume that Graham is a smart guy, that he doesn't get lost along the way, that he always wants to go closer to the library. Because otherwise there's an infinite amount of ways. Oh, I'll just go around this block 855 times, and then I'll go around this next block 3,000 times. Right? We're always going to assume he gets closer. So one way is 4 blocks east, 4 blocks south, made it. Okay? Another way, he could have gone 4 south first, then 4 east, made it. Or he could have went do, 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 do. And that would be another way. So if you just draw on your paper and count as you go, all the different ways, you know, this is, okay, how many am I at? You guys count them up. You got them? Is this a good strategy? Probably not, but it's kind of fun. It's going to be hard to count them all that way. So how do we show these? Well, this one, right? This is east, 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 south, 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 south. Where we could do this one. Oh, I like this one. This is probably the easiest way to get there. Oh, no, I did it wrong. I wanted to do, oh, it doesn't erase. Just go away. I wanted to do this one. This is the easiest way. Because it's east, east, south, 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 south. Doesn't that look easy? Oh. Oh. Don't acknowledge that. Thank you. So what's happening is each time we make a new path, the path will always be represented by 4 E's and 4 S's. And it becomes a Mississippi question of identical objects. Because every time you rearrange and get a different arrangement of easts and souths, you will have a different path. So how many ways could you rearrange those? Well, normally if they were all different, it would be a factorial. But we divide by 4 factorial and 4 factorial. And we would get the total number of ways that Graham could walk to the library. So we're going to get questions like this. I'm going to show you another strategy you can use for these pathway ones. But the pathways you can do by thinking about how many ways you need to go east, how many you need to go south, and doing it as an identical objects question. And that's the reason it's in this section. But we could also count it systematically. Here's Graham. How many ways could he get to there? 1 way. Would you agree that there's only 1 way to get to there? Are there any other places that there's only 1 way to get there? All the way across, right? Only 1 way to get there. Only 1 way to get there, only 1 way to get there, right? Only 1 way to get to all these down there. Unless you backtrack, but we're going to say that he's smart and he doesn't backtrack. How many ways can we get to this one? 2. Can you see that there's one pathway that's this way and the other pathway this way? How many ways can you get to this one? You can actually count them out. How many ways to get to this one? Think about the different pathways. There's only 3 ways to get to that one. You could go 1, here I'll draw them out. 1 way, 2 ways, or 3 ways. But then he's backtracking. So we're going to assume that he doesn't, oh, I'm screwed up, and goes back. Otherwise, there's an infinite amount, because he could just keep looping around forever. So there's 3 ways to get to that one. By symmetry, would you agree that one's 3? Yeah. Okay. Now I want you to start looking for a pattern. I'm going to put the next number in. There's 4 ways to get to that one. There's 5 ways to get this one, 4 and 5. This isn't going to be 4. It's going to be 6. And this one? 10. And this one's 10. What's happening? This one's 20, yes. And this one is 15. And this one is 15. Now, does it make sense if there are 15 ways that I can get here and 20 ways that I could get here? I can get to this one either by these 15 ways or by those 20 ways, making this one 35. And this will be 35. And then in the end is 70, which if you typed this into your calculator earlier, you would have found out that that was 70. Now, we can add and make this question more interesting. Oh, yes, we will. All right, here's Graham's house. Here's the library. And Susie lives here. And now, all of a sudden, every time that Graham is walking to the library, he happens to always go by Susie's house. How many ways can this be done if he has to walk by Susie's place? So we're saying, you're using the 1, 1, 1, 1, 2, 1, 1, 3, 4 to get to Susie's. Are you all right then with erasing this section because he'll never go here anymore? And erasing this one here. It's basically those 2 blocks together. Now, how many ways can he go to these spots? Well, if he's going to get here with 4 ways, he could get to this spot with 4 ways as well. And this will be 4. And this one will be 4. And this one will be 4. This one will be 4 plus 4, 8, 12, 16. That's one way we can think about going by Susie's place. There's now 16 ways. The other way we can think about going to Susie's place, okay? Can you see that going from his house to Susie's house is 3 easts, 1 south? And if we would do that, that's 4 factorial divided by 3 factorial, which is 4. That's his first decision. How am I going to get to Susie's? Well, I'll spell Susie's name with the Y apostrophe S. There we go. There's 4 choices to get to Susie's house. And then after getting to Susie's, his next decision is how am I going to get to the library? Well, the library from Susie's house is 1 east and 3 south, which is also 4 factorial divided by 3 factorial, which is 4. And if we do this as a spaces question with 2 decisions, 4 times 4 is also 16. So what we're going to start to notice is our strategies start to overlap. And depending on how we think about the question, we can solve it in different ways. Some strategies work better in some situations than others. I still like counting the pathways along the way for this one, for going past Susie's house. But if it was a super big grid, he lived in New York City or something, and he took him 3 hours just to walk to the library, and Susie's house was along the way, and there's just like tons and tons of blocks, then it might make more sense to use another strategy. Oh yeah, questions to do after this one, number 12.